Okay, my soon-to-be college or Calc AB students, I have not taught this before, and I went through the notes, and I'm going to try to help explain the notes that they have. They do a lot of work. It's kind of mushed together, so I have some separate paper here that I'm going to help you walk through the examples. So you should have gone through the chapter 7 and have done all the notes and examples, and this is kind of like the post chapter 7 that you need to understand for Calc AB, BC. So I'm going to give you, and we're going to talk about this. So it's called partial fraction decomposition. So the idea is they have a problem, and let me kind of go in the notes. And, we were adding and subtracting these rational expressions and getting an answer. So the idea is what we're trying to figure out is what were the fractions that they added together to get this. And so we're going to break it down to the original problem. So we went from the before to the after. Now we're going to go from the after to the before. So that's our goal, is what were the fractions they added to get the expression that's in front of you. All right? So first thing, they talk about the difference between a proper fraction and an improper fraction here. So a proper fraction, for instance, is 1/2, 3/4. It's where the numerator is smaller than the denominator. And then you have improper fractions where it's just the opposite, 4/3, 7/6. So where the numerator is bigger than the denominator. Okay, and our goal is to make these partial fractions so that when you compare the numerator to the denominator of these different fractions that you're adding or subtracting, that you have proper fractions. So what you're going to see happen is you're going to have 7, a constant, as a numerator. So that has technically a term of x, or sorry, a variable of x to the 0. And below it, you need to have x in a higher power. So we'll just build one up, so x to the first. So when we're talking about proper, and we're looking at the exponents that are attached to the variables. So if you have 8x here, then you need to make sure below that it's x squared below. And that's basically how that's going to work. So that'll pop back up in a little bit, more important later. So what we're going to do is we're going to start with the set of linear factors. So how do you decompose this? What did they add together? What fractions to get this? So what they want you to do, and what we've done before, is they want you to start by factoring. And you guys know how to factor this. So this is what they did. They had x squared plus x minus 2, and they turned it into this. Okay? So what they do now is they take this, they move it down here, and we're going to rewrite this as the two fractions that they added up to get there. So since this is an x here, there's a constant up here. Technically, if you really wanted to put it, they could have an x to a 0. So this is a proper fraction because it's a smaller numerator, bigger denominator, and the same thing here. But we don't need x to the 0, so they don't put it because anything to a 0 power is 1. Okay? So that's what they're doing. They're trying to figure out what are the numerators that we added together to get 2x minus 11. And it's not 2x and a negative 11. So she comes over here, whoever this person is, I don't know who it is, and what they do is, so I'm going to kind of take the example, 2x minus 11, and the denominator, sorry, I'm just rewriting it. I am putting parentheses around this. And so what they're doing now is what we did before. They found the least common denominator. It is right here. It's x plus 2 and x minus 1. And they multiply each fraction by that least common denominator. So this is basically what she's showing you on the next page. I'm just going to show you how she gets there. Okay? So take this times x plus 2 and x minus 1, and take this times x plus 2 and x minus 1. And then the denominators disappear because x plus 2 takes out this, x minus 1 takes out this, and you're just left with 2x minus 11. And then this takes out this, and you're left with a and x minus 1, and this takes out this, and you're left with b, and, whoa, sorry, you couldn't see any of that, and x plus 2. So if you compare there, this is what she has here, and this is how she got it. Okay? So what she wants you to do now, she talks about these things called nifty x's, and they're just the values that make your x become 0, or make your parentheses become 0, sorry. So 1 and -2. So her nifty x's, nifty x's, are 1 and -2. And so what she does is she puts 1 in to this whole thing, and that's here, and she puts -2 into this whole thing. And when she puts 1 into here, so I'm going to use her notes, you can just see 1 in for x, 1 in for x, 1 in for x. She's able to go through, and as she does this, she's able to solve for b. So b in this partial fraction that we started out with is -3. And then she does the same thing again, but this time she puts -2 into here. So -2, -2, -2. She starts to do the math. The b term disappears, and she's able to solve for a. So now she says, cool, so this is her partial fraction decomposition. Now that she knows b is -3, whoops, and a, what did she say it was? 5. I'm saying it's a she because all great math teachers are women. She goes back and she puts the 5 here and the -3 here, and now she has figured out the two fractions that she added together to get that answer, and here they were. So if we actually, in that section 7.4 where we were adding, subtracting, if I had added that and we'd done all the work, this would have been our answer. Okay, so that's kind of a basic one. All right, and it's called linear just because, these are linear down in the denominator. So then she goes to the next one, and then her work really starts to kind of jump ahead, and it's a little confusing. So let's take a look at her next one. And again, it's called linear because the factors that she's going to break this up into are linear. So the first thing she does here, and I'll write here, is she needs to factor the denominator. So she factors out an x first and gets x squared minus 4, and then the x squared minus 4 is that difference of squares, and she turns it into x plus 2 and x minus 2. So she goes from here to here. So she added some fractions together, and when she added them all together and did the math, this was her answer. So what she does is she takes this apart, and she wants her denominators to be linear. So x, and remember, this is proper because there's an x to the 0. The numerator is smaller than the denominator. So x to the 0, x to the 0, and she just breaks it up. So now we just have one more term. We have a c. So what she does, I'm going to go back to my paper here, is she takes, I'm going to rewrite it, so maybe pause it because I'm going to be writing this problem. Let me get a different piece of paper. Sorry. Okay, so she takes this whole thing. I just need some space. I guess I could have had this written already. Okay, so she has a over x, big space here. She has b over, sorry you can't see that, x minus 2, and then she has the c in the x plus 2. So she goes through and she multiplies each fraction, each term, by the least common denominator. So she takes this one by x, whoops. She takes this one. She takes this one. And she takes this one. And just like before, you start to see those denominators cancel out. So all of this is gone and all of this, and you've got 3x squared plus 7x minus 2. This x takes out that, so you're left with a and x minus 2, and x plus 2. This takes out this, so you're left with b, x, and x plus 2. And then this takes out this, and you're left with c, x, and x minus 2. So basically, what I just wrote here, all that, is what she has here now. Okay? So now she goes back and she looks at those nifty x's. What would make her parentheses turn into 0? And she realizes 2, -2, and because of this one, 0. Okay? So her nifty x's become 2, -2, and 0. So that's what she does first, is she puts 2 into this. And when she does that, so she puts 2 in, this is the left side of the equal sign, this is the right side of the equal sign, and she cleans it all up, she realizes she can get B straight away, and she gets 3. Then she puts -2. Here's the left side of the equal sign, here's the right side of the equal sign. A lot of stuff goes away, and she's able to figure out that C is -1/2. And then she puts 0 in, left side of the equal sign, right side of the equal sign, and she's able to figure out that A is 1/2. And then she just goes back to her original problem, you know, up here, and she puts her 1/2 in for A, she puts her 3 in for B, and she puts her -1/2 in for C. So that's what she does here. So the only thing that she does is, you don't have a fraction like this, she just moves the 2 down to the denominator and the 2 down here in the denominator. So this turns into there, this stays the same, and then she actually adds the opposite and puts minus. She could actually have plus -1 here and puts the 2 to all of this, and since it's going to all of this, she wraps that in parentheses. And now she knows that this was the original problem. When she found the least common denominator and added everything together, there was her answer. Okay? Alright, so let's go through example 3. So here, basically, what we're going to do is we're going to decompose this, and we're going to see what were the fractions that we added to get this problem. So what she does is, when she breaks this down into the factors, that x minus 2 is just repeating. So the differences in all the other ones are factors or different numbers. Here our factors are repeating. So with that, what you do, when you break it up, you start with one linear term, then 2 of them, and then you get it to all 3 of them. Okay? So what she does now is she takes her least common denominator, which is 3 of these x minus 2's, and she goes through and multiplies this fraction by the least common denominator, this one, and this one. So this time I wrote it all down first. So, whoops, except I did not put the x minus 2 cubed here. So the least common denominator is 3 of these x minus 2's. So I'm going to multiply this one by it, this one, I'm going to wrap that in parentheses, this one, and this one. And she goes through, and now let's start to cancel out the denominators. So first, this takes out all of this, and you're just left with 2x squared minus 9x. I'm actually going to go to the end. This takes out all of this, so she's just left with c. And this one, she's using the rule of exponents, that 3 of these and 2 of these would cancel out, so you're just left with 1 of these x minus 2's on top. So here she has b with x minus 2. And then 3 of these would cancel out 1 of these, so you're left with 2 of these here. And I'm actually going to write it twice for that one. So now she has a and x minus 2 with another x minus 2. Okay? So this is what she has here, except where I wrote the x minus 2 twice, she has it once with the squared. So now what she does, as she starts to get this a little cleaned up, and she goes through the notes, and first she talks about these nifty x's. So when you look at them, 2's the only one. Okay? So what she does for nifty x, she says is 2, is she puts 2 in, she puts it into the left side, she puts it into the right side, and when she does that, she's able to figure out that c is -10. What happened on the other one, we had so many nifty x's that she was able to figure out a, b, and c, but since she only had one nifty x, as she calls it again, she only could get c. So what does she do? So what she does is she ends up taking the fact that c is -10, and she'll use it in a little bit, and what she does is she gets this into standard form. So on the left side, she leaves it as 2x squared minus 9x. I'm explaining what she does here. And she multiplies this. So first, she FOILs this, and she gets x squared x squared plus -4x plus 4. And then the a multiplies into all of that, and so she gets ax squared plus -4ax plus 4a. And then she takes the b and distributes it in, and she gets bx plus negative 2b. And then she has the c. So what I'm showing you right here is what she has right here. Okay? So what she does now is, if this side is in standard form as ax squared plus bx plus c, like that, okay? What she does is she groups her x squareds together, which there's only one. She groups her x's together. So I'm going to kind of separate this out. And then she puts all the non-x terms together. So 4a, well, let's put a box, negative 2b and c. So 4a plus negative 2b plus c. Okay? So, and so we're getting to where she is here. So here's her ax squared, and then she goes to this one, so I'm going to rewrite ax squared, and she factors an x out, and so I'm going to put the x behind. And when you do that, you get negative 4a plus b. And then, again, this is just the constant here. Because there's nothing I can factor out of that. And what she starts to do is she starts comparing the left side to the right side, because if they're equal, then that means 2x squared and ax squared have to be the same. So if these have to be the same, she's realized that a is 2. Remember, she already knows c. She found that earlier. She realized that c is negative 10. Okay? So now we're just adding to the c is negative 10, now that she knows a is 2. So when she goes here, she knows that these two, that negative 9 has to be worth what negative 4a plus b is. And since she just figured out that a is 2, she puts that in there. And when she puts 2 in here, she gets negative 8. And when she solves for b, she realizes b is negative 1. And now and we don't need the other one because we already figured out what c is. So now she knows what a is, what b is, what c is. So over here I'm going to add that b. And she goes back to her original problem, which I'll show you mine. And she puts her a in, her b in, and her c in. So above the a, she puts 2. You can start to see her answer, 2. Above her b, she puts negative 1, but she writes it as minus 1. We could add the opposite to that answer and have plus negative 1. And then her c, where she had negative 10, she puts that, and again, she put minus 10, but we can put negative 10. So these are the 3 fractions she added to get to there. Hopefully the more you do this, the more this starts to make sense, although these are definitely not easy. All right, we're going to take a look at this last example, and then I think that's enough. I think you will be good to go. We'll take a look at some of these practice problems that you have there. Okay? All right. So now what's going to happen, the difference is we're going to start to see, instead of linear factors in the denominator, we're going to see some quadratic factors where the highest exponent is not a 1 but a 2. So the first thing she does is, same step, is she factors this. So she does the whole grouping method. And she takes an x squared out, and she gets x plus 3. Then she needs another x plus 3, so she takes a 1 out, and this is where she gets her 2 factors of x squared plus 1 and x squared plus 3. So first she just separates it out. Now remember, when you make these partial fractions, it's got to be a smaller numerator and a bigger denominator as far as you compare the exponents. So when she starts to break this up, and she has a, she puts her constant over the linear version, because this is, again, x to the 0, and that is smaller than x to the first. And then she takes x squared, but since this is a squared, when she goes for b, she needs 1 smaller power below it. And this is kind of what she's explaining here. And since the whole thing is x squared plus 1, after bx goes a constant, so she puts the c. So hopefully that makes sense. That's a little confusing. But again, the main thing is you got to make sure these are proper fractions. So if this is 1, this has to be a constant because x to the 0. If this is x squared, you have to start out with an x, and then in standard form you go down to the constant. Okay? So what she does again is she figures out the least common denominator, which is here, and she goes through and she just multiplies the whole thing by that least common denominator. So much paper. So let's go ahead and just walk through that and how she gets her answers. So here's the left side. This time I did not have it written down. Okay, so her least common denominator, she goes through, she multiplies it here, here, and here. Then she does her canceling out, so she's left with 4x squared plus x minus 3. Here she's left with a and x squared plus 1. And here she's left with bx plus c with the x plus 3. So what I have here is, where is it? What she has here. So again, she looks for her nifty x's. There is nothing squared that you can add to 1 and get 0. So her only nifty x is negative 3. So she talks about that. She puts negative 3 in. She puts negative 3 in here. She puts negative 3 in here. And when she's able to do that, she figures out a is 3. So there's one of her fractions. Okay? So how does she figure out the other one? Well, she does what she did before. So she talks about the fact that there is no nifty x here. That's this little part. So she does what she did before. She leaves this alone, and she distributes this a in. So I'm going to turn my paper around and just walk through that. So she leaves the left side as it is. She distributes this a in and gets ax squared plus a. Then she FOILs or distributes this, and she gets bx squared plus 3bx. And then she distributes a c in, she gets cx plus 3c. And then to make the left side equal the right side, she pairs up her x squareds. So ax squared plus bx squared. I'm going to leave a space. She pairs up her x's, 3bx and cx, and then anything that doesn't have an x, so a plus 3c. And then kind of group this, plus this, and you compare it to the left side. What she does is these are the x terms, so she factors out the x squared. I'm going to put at the end. She factors out the x. Again, I'm going to put it at the end. And then she leaves this one alone. Okay? So now what she's doing is she realizes that if this is x squared, then this 4 has to be the same as a plus b. And this 1 that's here has to be the same as this. And that the 3 here has to be the same as this. So we're going to go back to the fact that she knows that a is 3. And when she does that, she figures out that the b is 1. So that's where she goes here. And then if she knows that b is 1, or you could go here as well. She gets her c to be negative 2. And now that she knows those, she goes back to her original problem and just puts them in. And that's how she gets her answer. And that's it. That's your partial fraction decomposition.